So let's look at an example of a piecewise defined function where we are asked to sketch the graph, determine if it is continuous, and solve the equation f of x equals 0. Alright, so our function is f of x is equal to negative 1/2 x plus 4 if negative 4 is less than or equal to x is less than 2. Or it's equal to negative quantity x minus 3 squared minus 4 if x is greater than or equal to, let's make that a 2. Alright, so first let's sketch it. Alright, so the first thing that I'll do is get a grid going. Alright, so let me plot, I'll plot in green the function negative 1/2 x plus 4, and we have that function if x is negative between negative 4 and 2. So what I'll do here is we have the y-intercept of 4, and then the slope is negative 1/2. So we have a line that looks roughly like this. I'm going to assume that we remember how to draw this line. So that's the entire thing. But it's only defined if x is between negative 4 and 2. So when x is negative 4 and when x is 2, we only need that part in between it. So let's erase the rest. And I'll go ahead and erase those dotted lines now. Now let's look at the endpoints. We have a solid endpoint for the negative 4 because it's an or equal to. So this point at, what is it, negative 4, probably 6. And we would have an open point at x when x is 2. So at this point 2, 3, we have an open point. Now we look at the second part of the function, negative quantity x minus 3 squared plus 4. So notice that that's a transformation of the basic quadratic function with vertex 3, 4. So let me plot the vertex at 3, 4, and then it's opening down. And we could go and find things like, what is this x-intercepts and all of that. And in fact, if you found the x-intercepts, so let's see, negative x minus 3 squared plus 4 equals 0. So if I subtract the 4, divide by the negative 1, use the square root property, that would give me x minus 3 is positive or negative 2, so then x is 3 plus or minus 2. So that's x equals 1 and x equals 5. So I have x-intercepts at 1 and 5 and opening down, and so then the curve would look something like this. Now, again, it's only defined if x is greater than or equal to 2. So I only keep the part that's to the right of that boundary. So let me erase everything that's to the left of the boundary. And let me erase the boundary itself. Kind of clean up the graph. Now, that's only defined if x is greater than or equal to 2. So what's happening here when x equals 2? Well, let's look at f of 2. F of 2 would be the opposite of 2 minus 3 squared plus 4. And so that would be the opposite of negative 1 squared plus 4, which would be the opposite of 1 plus 4. Negative 1 plus 4 is 3. So notice that f of 2 is 3, and what we drew in green, the linear part of the function, would have also gone through 2, 3, and so we can fill in that point right there. So notice that these two pieces do actually meet up. So there's the graph. Determine if it's continuous. Well, the pre-calculus test for continuity is, can you draw the whole thing without picking up your pen? And so if I were to trace along, Forgiving my error for picking up. But I was able to trace that whole curve without picking up my pen. So this is a continuous function. All right, and solving f of x equals 0, well, I see that we have one point there where the curve, the function crosses the x-axis. So f of x equals 0 when x equals 5.